we've worked with radical equations quite a bit, and now we're going to look at equations with rational exponents. And remember that every rational exponent is just a radical. So again, as a reminder, if we have a to the m over n, that's the same as saying a square root, and then the nth root of a to the m. Okay, and again, we saw how to rearrange that a little differently. Okay, so then in this one, how might you solve this? I want you again just to think about this first for a moment. Okay, and so here, again, you could isolate the x and then write it as this, and really when you isolate the x, that's the same as saying, okay, you have the square root of x, right? The 1/2 power is the same as the square root of x is 9, and then we just saw to solve this, you would square each side to cancel the square root, and you'd be left with x is equal to 81. And you should check that this is indeed a true answer, and surely enough, if you do 81 to the 1/2, that's the square root of 81, you get 9. And then, so 9 minus 9 is 0. Yep, so that's going to work. Okay, but now you could encounter something that's a little bit more interesting like this, and I want you to think about how you would solve this. Okay, so pause the video and try it out. Okay, well, then minus 3/2 power, it might be throwing you off for a moment here. You could, make it a positive exponent in the denominator and then write it out as a radical, that's fine. I think I want to do something different. Okay, what I would really like to see later in my work is something like x plus 20 or x squared plus 21 to the first power, because then that's the same as just saying x squared plus 21, and I don't have to worry about foiling it out or doing anything like that. So my question is, if I do that, to get to the exponent of 1, I would have to play with exponents, right? So I currently have this, but if I were to apply an exponent to each side, what exponent would it be? So that I can say that the resulting exponent is 1. Okay, so this is going to be put in a quiz, so make sure to try it out. Think about properties of exponents before you answer. Okay, and so as the quiz revealed, the exponent is going to be minus 2/3. Okay, because again, you would multiply exponents, and so that would be a positive. You need a negative to make it positive, and then 6/6 is 1. So then whatever I do to the one side, I have to do to the other side. Okay, and then off to the side, I'm just going to come over here and compute 125 to the negative 2/3. So if I make it positive first, so that's going to be 125 to the 2/3 power in the numerator, right? I move it up, positive exponent, and now this is really the same as saying cube root of 125 and squared. That was one of those other representations, right, that you can represent it as this to the mth power, and this is the same as 5 squared, which is 25. Okay, so that's easier for me to work with. Okay, and then here we go. Okay, subtract 21 from both sides. I'm running a little bit low on room, so I'm going to come over here. X squared is equal to 4, and then x is plus and minus 2 when I introduce the square root. So I still need to go through and check my answer. I'm going to tell you they both end up working. So here, that's all I need to do because there is no solution set. Okay, so big idea here. If you have a fractional exponent, consider multiplying it by or raising each side to its reciprocal so that you cancel out the exponent and obtain 1. Okay, but then again, whatever you do to one side, you have to do to the other. Okay, big ideas here. The last video that we're going to do is going to continue looking at radical and rational, or radical equations and rational exponent equations, just with contexts.